All right, we're back online. If you're with us so far, we've covered quite a diverse selection of topics. We've covered attention mechanism and the mechanistic role and how it applies in computer vision. We've looked at applying computer vision to transportation biometrics. Those were very comprehensive presentations to tell you all the elements, all the considerations around those topics. Now we're going to dive headfirst into a presentation that is as diverse in topics as is the speaker's experience. So, Sivaram Anadurai is an AI strategy and AI solution architect with a wealth of experience in applying computer vision technologies across a variety of industries, including beauty, education, fashion, healthcare, cybersecurity, retail, and botany. I find that really fascinating, botany. Um, he's implemented state of the art AI tech, including computer vision, natural language processing, and deep learning. And without further ado, we're going to put his presentation on and off to the races.
Thanks for the kind introduction, and thanks everyone for taking time and joining this session. We have seen a couple of different perspectives of vision. So the next 30 minutes, we are going to look at in the complete loop. There is data from text, there is data from image, there is structured data, transactional data, how all these things are getting blended together. And from my consulting work, recent last 6 months I've been consulting ESG domain, industrial domain, real estate domain. So the diverse data set and the challenges for it, I'm going to give you the perspectives and what are the challenges we went through. The key takeaway is going to be for us in terms of the overall the data pipeline or the data platform, what it looks like. Few years back, very recently before the LLM moment, you have your data lake. You get all your slow data, fast data, big data, everything, and then you're going to consolidate everything into your data lake, and then you will run all your algorithms, predictions, everything. Uh, at now, when you look at a checkbook, you can do OCR. You can probably extract the values. What can I do beyond that? Today, with an LLM, you should be able to inquire who is the lender, what is the transaction, what is the amount, the money value. So the data that you extract is totally changed, and the amount of interaction and the insights that you can extract from video, insights that you can extract from text, from image, everything is totally changed. We look at some of those use cases and how the data platform is also getting changed, and how we try to, what are the different benchmarks, everything we'll try to address. So let's move ahead. A few key slides I'll try to spend a little bit more time. At a high level, we have right now we are in the stage of wherein like you use LLM in terms of doing automating some task, process automation, and in terms of chatbot, a few other support, code creation. I mean, it's at a stage wherein like it's not completely autonomous, but to certain extent there are certain tasks which it is able to do at high level of accuracy. And with this, the current market, if you look at it, these are all a few highlights, from different projects as well as use cases, and from the adoption, what you could see, white label LLMs. You see the big, large vendors trying to put their LLMs and benchmark against each other. But in terms of adoption, it's more about the use cases that we are going to do. There are domain specific models, small language models, and models which work with a high level of accuracy in a certain domain. That's something we don't see a lot of healthcare related model or a fintech other than index gpt or a FinGPT, a few other models. Beyond that, not much. And yes, responsible AI, we'll need to look at it in terms of the frameworks and things that we need to consider. And there is a model benchmark and there's a domain specific benchmark. For every use case that we try to pick, what am I going to infer? Like for real estate, I'm going to make a query. What are all the 2 BHK bedrooms available? Then it's going to return response as an image, or it's going to return response as a text. So these things we need to consider. So the benchmark need to be according to the use case. And again, when you have diverse data sources, you are going to have data quality issues. What is the data quality from structured data? What is the data quality in the image data? what is the data quality in a text data. Everything has to be thought through. And multimodal CDP, getting all the different data and how you are going to blend it together, that is something, there is a change in the data patterns, we'll also look at it. And yeah, adoption use case also we'll try to look at it. So a quick look back, like, all of you would have seen the digital business transformation movement, the cloud movement, and AI movement, generative AI movement. So kind of, you should look at one of the recent tweets wherein, like, the more than process automation, in terms of trying to the cognitive transformation era, probably when you look at digital business transformation, wherein you take all the data, you create a data lake, and then it helps to speed up in terms of your analytics, in terms of your reporting, in terms of handling both slow and fast, all the different types of data. But then, how many AI use cases I can do, how many models I'm going to build, what is the power of those models? Can the model be used to reason? Can the model be used to do a sequence of tasks? Those things are the things that are changed in the LLM moment. Very precisely, this is the slide what I want to touch upon. This is a very reference architecture from Azure Data Platform. Like, this is more of a data centric AI. You get all the data, all your fast data, slow data, all of them, and then it goes into your databases, and you have your AML Azure Cognitive Services Platform, where you try to ingest it, and you try to do your predictive insights or recommendations, whatever you want to do. How does this change, and what is the difference in ESG projects or real estate project? Where is the difference? I'll try to come to it in the probably next slide. So let's look at multi-model or vision. Uh, these are certain insights. When you look at an image for a beauty product, when you have a model with applied beauty product and the inference, there is a conversion rate increasing 27%. When you have a makeup that's being done, and you put a picture of a closed versus near or far view, then there's a conversion difference. And between an indoor and outdoor view, there's a difference. So these are all different elements which is there, which impacts the way we buy. And any image for a product that you buy in any of your retailer, you're going to look through them, and then you're going to buy your product. And in these cases, uh, earlier maybe you would have built a custom model to say it is far, it is near, it is indoor, it is outdoor, and what kind of products are out there. All these things you'll be doing. But in a with this current multi-model, be it your reasoning models or text models, you're going to have multiple different data supports, like your product manuals, sales data, demo videos, digital asset management. All of this data could be used, and you can extract data based on image, based on text, a custom fine-tuned model, domain-specific model. And then the storage is, when you look at the Azure storage, you saw some of SQL, no SQL. But here, vector databases are going to come and play a role. And the way how you store, am I going to store it in an aggregated way, or I'm going to store it in a probably an extracted with insights data, and how all these collections are going to be set up. So this changes. Even consider a simple example for a damn digital asset management. The number of rules that has to be run: near view, far view, side view, eyes present, hands present. There are a checklist of things, and then you identify whether it can be it's a good quality image, or can it go to the next level, can it go to the website or not. In a typical computer vision era, you're going to work through all of it, and then you need to generate it. But now with a multi-model, you can it's as simple as writing a prompt and then getting a response, and then based on those responses, you can look at, okay, whether it goes to next stage or not. Obviously, you need to benchmark, you need to see what categories work, you need to see what categories don't work. But again, the bar for adoption, and it can be an ensemble of model, but the quality checklist, all this could be 10 different model which you have to collect data, train data, and then test, and then go to production. But now with the multi-model reasoning models, you should be able to uh, have much more faster adoption. And the accuracy also, it's not going to be, you don't need to collect the data, you're going to take a already pre-trained and a large language model. And in terms of digital asset management, reworking on a product attribute or the search engine optimization, and trying to find similar matches. All of these things, you have a lot of vision, plus the search engine optimization and reworking on the digital asset management, plus image to super resolution, creating variations and enhancing the attributes, background attributes with the image to image models like Stability AI or Midjourney. And when it comes to search, earlier when a user gives an image, this is one of the use cases where we have to do a segmentation model. We have to extract the faces. Then I have to run a gender detection model. Then I have to do a age estimation model. Then with all that, then one more is indoor or outdoor. With all of them done together, we had a rules checklist of with all these things. I know then I'm going to recommend from that category. But today, if I had to do it, I just need to pass the image, and then with a few prompts, you would know the age, you would know the gender, you would know what type of dress that they are wearing for the occasion and what you can recommend. So the difference from data centric AI, AI centric data, whatever we saw earlier before the LLM movement, wherein you have individual specialized models which were developed, and those models were trained to do specific amount of task, but with a multimodal, a large language model which can do image translations or image reasoning or a summarization of the product reviews. So now if you look at it, even within retail domain, you can use chatbots, you can use recommendation engines, and you can do the insights analysis of store performance, plus the text based sentiment models. So every aspect of data, what you earlier you might be ingesting the product manual, but were you doing a Q&A based on a RAG or LLM? No. Now it all of this data is going to coexist. Some queries might go to knowledge graph, some queries might go to a vector DB, some queries may go to a structured database, and you might use a text to SQL to convert a user query into an LLM query and then get a response. So this multimodal CDP, wherein like, I mean, I like this picture wherein like, the DBT is where you translate and store, but then having the LLM work on top of it in terms of automating process automation, productivity improvement, all these things are the key aspects. So this is more about vision, and in terms of vision in retail, the different multimodal and how we try to solve different use cases. Uh, I hope this section gives a clarity in terms of multimodal adoption in retail and the data platform in retail, from focusing on structured unstructured data versus extracting knowledge from image, extracting knowledge for DAM, and then automating the complete digital asset management and the different use cases. I hope that section is clear. A little bit we need to deep dive in terms of robotics as well. I'll quickly touch upon it. We would all know, I mean, robotics, industrial automation has been there for a while, and this is in terms of the adoption of robotics and where it works, where it doesn't work. If you look at it, robots are very good specialists, but in terms of specific tasks, they have the challenge. But those specific tasks is what, if you look at some of the recent CVPR paper, uh, reasoning of the task, segmenting of the object, marking the boundary, and generation of what are the objects present. All these things are kind of solved with the large language model based tasks, wherein like you now have multi-model benchmark data sets for different kind of data sets. You have benchmark data sets, be it in the news or social media or industrial domain. We look at some of the examples. So the part of industrial automation is there, but having these large language models to blend it across, that is still going to take it to the next level. So this is a benchmark data set in terms of large language models, wherein like you can see the multimodal benchmark data sets in finance, sports, news, and art, fashion, wherein like custom trained models with this benchmark data set, they will be able to perform better in domain specific tasks. Um, if any questions, maybe I'll take it right now. I have few more slides to cover, but I hope if any questions at this point, I'll be happy to take it.
There's no question so far, but if any come in, I'll be sure to prompt them for you.
Cool, awesome. I just want to be sure like my system is not stuck or like sure, awesome, great. So let's move one step further in terms of multimodal innovation, in the sense the different use cases in each vertical. These are all certain specific use cases wherein like more than the uh, model aspect of it, with each domain, with every domain you have to deal with the domain specific data. We'll look at a few examples in the next two slides, but this is the upcoming trend in terms of multimodal applications. So again, what does happen under the hood? Basically, understanding of the image, and then identifying the objects in the image, segmenting the areas, generating uh, uh, the different objects and identifying around it. So these two papers, what we see, pixel prompting and multimodal benchmark data sets. These are all certain things which we have to consider in terms of building our own domain specific use cases. So, what is the key thing, the difference? Earlier, the data centric AI, the key part is consider all your text data, image data, relation data, or video data. So, when I worked in industrial domain, I had to do some domain specific words in terms of lighting, wiring, mounting, screws. So, these are all some domain specific context where you need to understand for that manual or product manual to work with. Second, how each of the certifications, voltage, all these values are being interpreted, because the model may not have an inherent ability. So until you fine tune and get your custom model, you need to look through that aspect of this pre-processing layer. The next one, what multimodal is going to play a role. The product manual might contain a product chart. A real estate marketing brochure can contain a map, and that map could contain schools, colleges, malls, hospitals. So when you if you need to get the insights for different types of data, it could be getting an insight from chart, it could be getting an insight from a map, it could be getting an insight from a product specification. So accordingly, we need to build our pipeline in terms of understanding the insights from each type of data: image data, chart data, video data, industrial domain data, real estate data. All these things play the key role, and it's not going to be one model. In an healthcare, you may be doing a healthcare specific model. In a financial security exchanges filing, you might use a custom model which is able to identify the lender, borrower, or stock value, or earnings per share, certain specific things. So this new layer of getting the insights with a suite of model, that's going to be the key thing. And your storage, your SQL, NoSQL, and then your BI systems, prediction systems in terms of forecasting and what we try to do. The two category of RAG or knowledge graph. Like think about it. If I ask, I need a product, I need a lighting for this residential complex. I need it with this certification, and I need it for this particular capacity. Then this becomes a set of 4 to 5 different questions. Can I do with RAG? You need to first parse the question. You need to understand what is the sequence, how it has to be answered, and then you need to solve it. So certain cases, knowledge graph can play a key role when you are able to, when you are asking questions which need multiple attribute. Certain cases wherein it's what is the certifications for this particular product, then RAG might play a better role in terms of answering. So your storage systems are also have changed a bit. And in terms of serving layer, uh, you make query based on natural language support, wherein like you do text to SQL support, and you might have your reporting system and insights and predictions of forecast which could be done. This is a little different from our data platform, what we would usually look at it. Sharing some of my project benchmarks for one of the ESG related project which I worked. The challenge was, like you see, if you sum up, there are around 700 pages. There is data point in each page. Every page might contain, it may be a chart, it may be a graph, or it might be a table. But we need to look at the metrics. The metrics could be in terms of emissions, usage, and greenhouse gases, DA inclusion, and employability index, or all of the metrics which is out there. We need to understand, analyze, and extract accurately. uh, I benchmark multiple models, like starting from Olama, running it locally, GPT 3.5, GPT 4, GPT 4o mini. And it's always a trade-off between cost and accuracy. If like you see, I mean, there are multiple attempts and errors. I mean, obviously, when the number of pages increase, the cost is also going to be high, and validation of it, how we are going to do it in an automated way, that becomes a key. And which model performs better, and again, the cost of each of the model, it's a trade-off between cost, accuracy, and infra cost. I mean, model cost, infra cost, and accuracy, what you want to achieve. So there's, it's no clear cut answer like how much open source models can achieve or how much each model can perform, but purely it depends on, when we don't have a custom fine-tuned model, the key thing that becomes is, how do I extract multimodal data information, like a page contain a chart. So in that case, identifying it's a chart, passing it to a GPT-4o model, and then extracting the insights. The page contains a graph. So sorry, page contains a graph. Then with this particular graph, what kind of information that you are extracting. So this is something which I have done in ESG domain, and maybe in real estate also. For real estate, again, we have the same challenge. You get data from external data, Google API data, the data from the web, and it's not one model. There are different pipelines which we run through. We try to look at the accuracy for GPT, GPT-4o Mini, Claude, Llama 3, and then you need to again do a balance between which is most accurate and which is fastest, which is the balance of speed and accuracy. So now your knowledge information is image, document, numbers, PDF. Uh, all of this are part of your data platform. So ingesting them and a custom ETL for it, and using a diverse set of models, which could be extracting the text or looking through images or looking through graphs, charts, all of them. Then the AI centric data, like that's the key difference now where we are. So if I have to put everything together, so you need to have the diverse set of inputs: text, image, structured data, video, and then the domain oriented preprocessing, and then domain oriented models and ETL pipeline, and your storage layer, your serving layer, and a governance layer. Obviously, cybersecurity and responsible AI becomes a key aspect of it. It's not that every model is a lift and shift, and this kind of puts the AI centric data approach, wherein like for Gen AI or any of the recent LLM based architecture, what is the difference between a traditional, probably your DBT architecture, or what other things that you had. Here, the specific importance is given more towards the extracting the insights and what type of models you're going to use. And then once this data is all ingested, then you can have your own agentic approach or agents which can do external research, next best action, human follow-up, or getting the leads, all of it. So overall, the landscape of tools is huge. Like, these are the different set of tools, specifically now with the AI and infra approach: foundation models, storage, retrieval, ingestion, retrieval tools, and your vector databases, prompt management, all of them. This is more of a tools landscape. This is more of a adoption landscape. So these two are the key things which I wanted to share. A few more things in terms of responsible AI. I hope this picture you might have looked at earlier as well, wherein like uh, a pedestrian, I mean, if it's a self-driving car and there are pedestrians crossing the road, how it is going to take a decision? Is it going to save the people in the car or people on the road? And again, every model has its own benchmark. Every model has its own bias. Every model has its own cost of fine-tuning. So building solution is one thing, but understanding the strength and weakness and the trade-off between time, cost, what is your infra cost, and what is your trade-off for accuracy. Everything is the key for you to pick a choice of a model. And again, you need to be very clear about the bias which exists in the model. And guardrails are not going to remove the bias. Guardrails are going to prevent anything being shown to the user, but still it's not going to remove the bias from the model. This is something as a summary of all the vision projects that I have done for 5 years since 2020 in my consulting world. Like, there are two failed projects. One project is kind of like worked on few use cases, it didn't work. and one project was published as a paper. But the last one for Unilever, what went live, the good thing is, we had an adoption of vision and multimodal. We had deep learning, we had LLM, and we bought data externally, and as well as in-house data for us to build a custom model. We had guardrails. Sorry. So it's a blend of success. If you ask me, it's a blend of multimodal vision models plus Google text models, custom guardrails, building custom deep learning models, and build and buy data equation. This is more of there is no success or failure story. Every failed project helps you to go to the next level. But again, every project has its own challenges which we need to look through. We are right now in a Gen AI era where you get consistency, accuracy, latency, but the responsible Gen AI era is consistency, accuracy, availability, and observability. Uh, we are doing AI innovation at this point, responsible and beneficial. I mean, the audit part of it, complaints part of it, it's still kind of discussed. And again, AI assisted, it's not human collaborative. There's no ethical oversight at this point. The model has bias, but again, we are all working towards building a comprehensive framework for it. And if I have to summarize the discussion, what we have done till now, the shift from data centric AI, what you typically see, streaming data, and then sales data, and then fast moving, slow moving data, sensor data, versus PDF document, images, text, video, AI centric data. And digital transformation, again, putting everything and do predictive analytics or do your insights dashboard reporting. Cognitive transformation, every type of data has a knowledge out of it. How do I use the custom set of models to extract the knowledge? How do I extract from a table? How do you extract from? And it's not just extraction. How accurately I extract? What is my bar to enter in terms of reaching the next level? And how much accurate I'm able to achieve? What is my effort and investment to get a highly accurate and reliable system? And again, the context cross domain. Today, if you're working in a finance domain, I can do web crawling, I can get Google API data, I can ingest all the company's previous reports, and then I can prepare insights out of it. I can try to look at the country's political landscape and the current sentiment, and then use them for investment analysis and recommendation. And again, depending upon the context of data, for PDF, for image, for text, for structured data, you'll have your own models, which is going to do uh, uh, the insights are not going to be like extract only 10 things. It's more about go through the complete documentation and extract all possible knowledge. That difference is one of the key thing. And again, with all these things being in place, the trade-off of accuracy, consistency, accuracy, latency, what we saw in the ESG benchmark table, and what we see in the real estate implementation, it does require an extensive implementation. It does require the effort to tweak your custom rack, or building your own custom pipeline, or adding your own guardrails, having a custom flow of ETL which can handle different types of data within a document, and domain specific learnings which you need to ingest. Those are all the key aspects in terms of building a multimodal data platform, as well as the different uh, insights which vision can provide. What you see in digital asset management, how a big checklist which used to be a 20 different vision model, now it's more of one single prompt. But again, choosing a model which gives the right prompt, that becomes the key aspect of your learning, and how you are going to address the responsible AI implementation, and how all of the data is going to coexist, how we are going to update the data. All of these things are the key aspects of it. But yeah, I mean, I hope this vision related use cases and one or two my domain use cases and benchmarks provides the clarity in terms of the multi-model data platform, and the data centric AI to AI centric data, and the ETL. What is the change in pattern that you can see in your use cases?
We have
Um,
one question in here.
yeah,
Parimal is asking, what techniques are employed to optimize, reduce the processing while solutioning in multimodal? What's CDP? What is that?
Good question. Yeah, customer data platform. Good
considering the
question. All
condition?
are very, very good questions. I mean, let me take the first question.
Mhm.
See, there are two things. One is when you have 500 pages of data, obviously it cannot be real time. And again, 500 pages of data may not contain all the relevant information. So it is more to do with what a benchmark for every model. Like, I think I need to show one particular slide. Every model, whatever you plan to buy or incorporate, this is a multi-model benchmark. Like here, if you can see, it says, on financial data set, document Q&A, math, science diagram, chart Q&A. So every model what you are going to buy or use has some benchmark which has been done. It is suitable for a certain kind of data. So that kind of decides us to see, okay, my task is more aligned to what particular data set, and that you can pick and choose. And obviously, benchmark becomes the key. If your domain is so very different, we probably need to take one or two models and then benchmark against them and see which does better. And these are all, see, latency and time and processing, all things are interrelated. So, acceptance part of it, obviously, the first part is you need to run and you need to see which model is giving the highest accuracy, and then you need to run on you need to have your own custom data set. That's what the first thing what we put up is, the domain benchmarks are more to choose a model, but your custom benchmark, data quality, edge cases, and what is the benchmark for your data and what type of rules you have, those things you need to have a clarity in terms of how you get the data. Is acceptance criteria decided beforehand? That's a good question. I would rather ask the question in a flip way, like, if you are already using a natural language processing engine to extract data for a security exchanges filing, you will be looking at, I look at this 10 data. Today, I run a ETL pipeline, which gives me this 20 field. So you already have a system in place, which probably might be written with some NLP and entity recognition model to extract that. So now with LLM, you are again going to run against those benchmark and going to see, okay, this the custom code what we developed, it extracted this 50 attribute. This is the value for it. With some LLM RAG and prompt, I have extracted the same amount of attribute. How much of it is matching? How much of it is different? How much of it is partially matching? So that way, it kind of helps you in adoption. See, now it's LLM is more like you are using an external agent, but how much of the knowledge the person has, what tweaks you want to do, and how you want to achieve, that is something comes with your own benchmark and your own data set, and how you see, like, do I need custom prompts for it, or do I need to use an ensemble of models, or do I need to use for this particular category of use cases I see a failure. So this is mostly domain specific, but again, you are not going to replace or build anything from scratch. For everything what we are trying to do, you would have a legacy system which probably would have been written with some NLP and deep learning techniques, and we can easily use them to benchmark. It's a staged adoption. You cannot stop on it because accuracy never changes. Going from 50 to 60, 60 to 70, 70 to 80, it's an iterative thing. Parimal, that's a lot of question, but very good questions. Thanks.
I really appreciate the more expansive view that you're taking to exemplifying the state of computer vision and how it's interrelated with the core tenets of data science and infrastructure management and managing costs, because things don't exist in a vacuum. Things don't exist in isolation. You still have to answer to somebody to pay the rent or the electricity bills, right?
True.
You can't just brute force everything and expect your mission to be accomplished. We have to work within constraints. Um, if anybody else has any more questions, I know this one was particularly technical. So, for the people that are not technical, I hope it gives you an idea and understanding, a sneak peek behind the curtain, that it's not the looming threat or the danger or the perceived fear of Terminator-esque world coming to play tomorrow is not going to happen tomorrow. There's a lot of work that needs to be done for this discipline, for the industry to mature, and for more people to adopt these technologies and gain experience. But we're all trying to figure it out as we're moving forward in this multimodal, generative AI driven world. Sivaram, any final thoughts on the state and where it's going with
Yeah, I
you,
think we would see a lot more adoption in terms of the number of use cases. Like from we are reimagining the workflow. Today, it's more like you are using it for one or two use cases. Think about it. Vision is used for virtual try-on. Vision is used for product defect assessment. Vision is used for probably digital asset management, and your all your invoicing. It's using some context of OCR and reasoning to find out who is given the lowest quote, and then you open your Copilot, and then it gives you the code, looks through it, and gives you whatever the code fixes. See, every other function is going to have the impact across. So think about a reimagined workflow. It's not about adding one or two use cases. It's more about reimagining the complete workflow, how the new age functionality is going to look like, wherein like you enter the store and then you have a list of recommendation based on what you have bought. It's not going to be static, but it considers the time, it considers what you have bought, it considers your actions. So I think this is the more of the excitement, wherein like you will see uh, uh, the reimagined workflows in retail, fashion, which is going to, and even in your social media, the way you read news, all of them is going to have an impact. Any multimodal cost effectiveness. See, I had the same question from many of my customers. See, the point is, OpenAI has spent few billions to reach an accuracy. Olama and few other models, they will get an accuracy to some extent. But think about it, the data used, the reinforcement human learning feedback done. You can do 10 patches and reach an accuracy what OpenAI can do. But somebody has to invest in preparing the 10 sequences to reach to that accuracy. Uh, the open source does exist, yes, for a reason, but accuracy, time to market is something you have to decide. And again, OpenAI also, think about it. I use OpenAI GPT-4 mini model. It's one fourth of the cost. Versus I use Olama, I get 20% accuracy. GPT-4 mini, I get 50% accuracy. GPT-4, I get 80% accuracy. It depends on the use case and what you want to go to market. And again, not everybody can train a large language model, and not everybody has the data to plan and prepare.
quick interjection. So there are two questions, and I don't think we're going to be able to satisfy them both. But maybe we can consolidate this into the panel discussion. Parimal is asking, are multimodal?
Yep, I
Uh,
answered them. Yep.
okay. And then Agrim is asking, can we conclude this into three takeaways? I
Yep,
think
three key takeaway. Vision is playing a key role. In terms of vision multimodal, you're going to have your new set of the data insights, which is going to be there. And third is consider the reimagined workflow in every domain where you can extract knowledge from vision, you can extract from video, you can extract from audio, you can extract from text. That's the key outcome.
well, with that, thank you very much, Sivaram. We're going to take a brief break. I want to say like 7 minutes, and then we're going to get the show on the road for the panel discussion. That's going to be a very open dialogue. If you're technical or non-technical, we're going to discuss some of the ethics and other considerations around how to adopt these technologies responsibly. So we'll see you there. Thank you, Sivaram.